Hi everyone, Assalamualaikum warahmatullahi wabarakatuh and selamat sejahtera. Okay, so dalam video ni kita nak masuk ke chapter 4 part 9 which is Laplace transform using second shift theorem. Okay, so now if you have a look at the keywords here, second shift theorem, meaning that the Laplace transform that we are going to evaluate is somehow related to the function that contain step function. Sorry, the unit step function. Okay. So let's have a look at the step-by-step on how to find the Laplace transform using second shift theorem. Okay, so first of all, you need to write down its step function. Okay, so basically, let's say you are given a graph. So based on the graph, you need to write down the step function first. Okay, so after that, you need to change the step function into the unit step function using this formula. Okay, so it depends whether you have 2 step function or you have 3 step function. Okay. Then, step number 3, you need to rearrange the equation so that you have in term of t minus a, h t minus a. Okay, and then lastly, you need to apply the second shift theorem, and then you can able to apply the Laplace transform. Alright. Okay, so now let's have a look at the following example on how to apply the second shift theorem in order to solve the Laplace transform for the given function. Okay, so basically this is the graph represent this function. Okay, so from the graph you might see that it is a type of step function where you have 2 different steps. Okay, and then step number 1, you need to write down the step function. Okay, so this is the step function, you just rewrite it. And then you go to step number 2 where you need to change the step function into the unit step function. Okay, by using this formula, right? So based on this is your G1 and this is your G2. This is your A value. Okay, so now your Ft is given by G1, which is 2t, plus G2 minus G1. So negative 1, negative 2t, multiply with ht minus A. So A is 3. Okay. And then after that, once you change it, you need to make sure you have the equation in terms of t minus a and ht minus a. So from here you have t minus 3, but here you don't have t minus 3, so you need to rearrange this equation. Okay, so you have negative 1 minus 2t. So what you can do, this t you change with t minus 3. So negative 1, negative 2 multiply with t minus 3. Okay, so in order to cancel it back, you need to minus with 6. Okay, and then negative 1 and negative 6, you got negative 7. So finally what you have, negative 2 t minus 3 minus 7. Okay, and then once you have the equation in terms of t minus a, so you can change it back in you can substitute it back into here. So finally what I have, ft is equal to this. Okay, so because I change this into this, and then I can rearrange it so that I have 2t minus 2t minus 3 ht minus 3 minus 7 ht minus 3. Okay, so now you have t minus 3, t minus 3 and t minus 3. Okay, so now the next step, you need to apply the second shift theorem and then get the Laplace transform. Okay, so Laplace transform for function of ft is equal to 2 Laplace transform of t minus 2 Laplace transform of t minus 3 ht minus 3 minus 7 Laplace transform of ht minus 3. Okay, so for Laplace transform of t, you can refer to here where the output is equal to 1 over s squared. And then for the Laplace transform of ht minus 3, you can refer to here. So in this case, a is equal to 3, so the output should be exponent negative 3s over s. Okay, so for here, you can apply the second shift theorem. Okay, so in this case, a is equal to negative 3. So ft is equal to t. Okay, so finally, what you have 2 over s squared minus 2 exponent negative 3s Laplace transform of t. So from here you have t minus 3. So it is considered shifted by 3. So now you have Laplace transform of t. And then minus 7 exponent negative 3s over s. Okay, so the Laplace transform of t is given by 1 over s squared. So finally what you have, 2 over s squared minus 2 exponent negative 3s over s squared minus 7 exponent negative 3s over s. So this is the output of the Laplace transform for evaluation using the second shift theorem. Okay, so basically, if you remember, you had learned on how to solve the Laplace transform for step function using the definition of Laplace transform. Okay, so basically this is the exact same step function. Okay, so we might say that the final answer is just the same, right? But because of the process of the integral is quite tedious, so that's why we propose you to use the second shift theorem method. Alright, so thank you for watching. Bye.